Alright, so I'm going to go over the mixed Claisen. The Claisen normally happens with two of the same types of esters, meaning literally like they're identical. This is a chart of non-identical esters, so it is mixed because they're non-identical. So it's the mixed Claisen. The first step in the Claisen mechanism to get your product at the end is to find your alpha carbon. So you might ask, well, how do I find that? The carbon, that's the alpha, is always next to a double bond O. So here's a carbon that's next to a double bond O right here. It has 3 H's, 3 hydrogens. So this is the alpha. The reason why it's the alpha is because it's next to the double bond O. This has the double bond O though. So why isn't this one the alpha? Well, because carbon can only have 4 bonds, and in fact, this already has 4 bonds, so there's no hydrogens. If there's no hydrogens that the carbon has, it's not available to be the alpha in the first place. So, yeah. And now, so we know that this is the alpha now. I'll go through the mechanism for the first one, and then the rest I'll just show you how to get the answer real fast. So since this is the alpha, we now have to ask ourselves step number 2, which is find the beta. Well, since this is the alpha, we know that this is not the alpha, and the beta is always the carbon beneath the double bond O. It's always where the alpha is going to attach to. So alpha goes to beta. Okay, so the first step is done, and the second step of finding the beta. The third is, all right, let's see, we can continue with the mechanism. This is a base, and it's acid, or an acid, or it's a solvent. So the negative, partially negative OET there, the base, comes, grabs the H. The electron from the H here goes towards here, the double bond O there. This bond comes up, makes this O negative. This negative then comes back down, makes the double bond again. I'm sorry, I forgot to write the double bond here. Because when the base comes and grabs this H, this bond gets recreated here. So when this electron came here, it made this bond. This electron is there. Came up, made this O negative, came back down, and kicked off this again towards the alpha carbon there. That makes this negative now. Next. Alright. Since alpha gets attached to the beta, you're going to go doo-doo. Go here. And since that happened, carbon can't have 5 bonds, so something must happen. So you're going to repeat kind of like what happened here. Okay? This is going to come up here because the alpha got attached to the beta, and now it can't have 5 bonds, so one of these bonds there must go away. How that bond goes away is this electron creating that double bond gets up here by the O, makes it negative. It comes back down to recreate the double bond to O, and now that we have 5 bonds again, like for a nanosecond, this ester, this OET group here gets kicked off. So it's gone. So the alpha went to the beta. Okay, so now that we went through the mechanism of the mixed Claisen, you can just fill it in because the mechanism is exactly the same for each one of these. And OET ends up getting kicked off, and the alpha gets attached to the beta. So now we can write our products. And okay, so we got here. This is beta. let's write our alpha next to it, because alpha gets attached to the beta. So what we can see here is that this group here, the C, double bond O, OET, like, is here. Sorry about that. It's right there. This is here. But without the OET. So this is our product now. Now, we can literally go through and fill the rest of the chart in now. So we go, all right, since I know my alpha, this must be the beta.